Alright, this video is over skill 29, solving equations with logarithms in them. And we're looking at two examples here, and I want to start out by just drawing your attention to one major difference between these two equations. Notice that in this one labeled number 3, two of our terms on the left side have a logarithm, base 7, but the right side has no logarithm. In contrast, if we look at example 4, every single term in the entire equation has a log base 9. So if we start out with example 3, we're going to start by using our properties of logarithms to condense the left side. I see that these two log base 7s are being added, so I'm going to condense them to give me log base 7 of 4x times 6, and the equation still equals 2. I can simplify the argument of this log to just make it log base 7 of 24x equals 2. Now there's multiple methods we could use at this point to rid ourselves of the logarithm and try to isolate x. The simplest way, however, is going to be to rearrange the pieces of this logarithm so that we can rewrite it as an exponential equation. Remember that any logarithm can be rearranged so that the base to the power of the other side of the equation equals the argument. So in this case, we can rewrite this as 7 to the second power equals 24x. I'm then going to just simplify this by rewriting 7 squared as 49. And I have one more step to isolate x. Divide both sides by 24, and I get my final answer, 49 over 24 equals x. If we look at example 4, which remember is different from example 3 because every single term has a logarithm, we're going to have a similar first step. We're going to condense the left side of the equation. So I can rewrite this as the log base 3. Oh, there's a mistake right there. I'm going to rewrite this as one moment. Alright, there we go. Sorry. I'm going to rewrite this as the log base 9 of 3 times the quantity, x plus 9, equals the right side, which is just the log base 9 of 66. Notice that here, because I was adding the two logarithms, I could multiply their arguments when I condensed. Now, in this case, I actually do not need to go to the trouble of rewriting this as an exponential expression. I could think of this just as being 9 to the entire power of the right side equals the left side. So I could think of this as being 9 to the log base 9 of 66. Remember, this entire right side would have to be the exponent, and it's going to equal 3 times the quantity x plus 9. I could do this. And remember, this would simplify. 9 to the log base 9 of 66 would just simplify to give me 66. So I could rewrite this as 66 equals 3 times the quantity x plus 9. However, there is a slightly easier way to do this. And so if we look at the slightly easier way to do this, that way is just going to be to look at the fact that on both sides I have a single logarithm, a log base 9, and I can just set the arguments equal to each other. Because if both sides are taking the log base 9s of some quantity, and both sides are equal to each other, then I can conclude that 3 times x plus 9 is just going to equal 66. I can distribute to give me 3x plus 27 equals 66. I'll subtract 27 from both sides, so I get that 3x equals, what's that going to be? 39. Divide both sides by 3. And so I get my answer. X equals 13. Remember, the most common mistake I'm seeing here is people treating these two types of equations the same. Not noticing that in this one, we do not have a log base 7 of 2 on the right side. We only have 2. So we have to rearrange it. Alright, this was skill number 29.